In today's video, we are diving deep into one of the most transformative trends in cloud computing, serverless computing. Serverless computing allows developers to focus on writing code without worrying about the underlying infrastructure. It enables businesses to build and run applications and services without the need to manage servers, leading to increased agility and cost efficiency. By the end of this video, you will have a solid understanding of everything serverless, from the basic concepts to real-world examples. So, let's get started. First things first, what exactly is serverless computing? Despite the name, serverless doesn't mean there are no servers involved. It simply means that you don't manage the servers. The cloud provider takes care of all the server management, scaling, and maintenance, so you can focus entirely on writing code and building features. Let's take an example of an image processing application that automatically resizes images when they are uploaded by users. In a traditional server-based cloud computing models, this application would be deployed on a dedicated server that constantly runs, waiting for image uploads. Even if there are no images to process for long periods, the server would still be running, consuming resources like CPU, memory, and storage, essentially staying active 24/7 just to handle sporadic requests. This means you'll be paying for compute power even during downtime, when the application is idle, which is both inefficient and costly. With serverless, you can skip all that. It's as if the infrastructure becomes invisible, hence serverless. You don't have to worry about overpaying for unused resources. The servers are only active when needed, meaning you are billed only for the actual time your code is running, saving both money and operational effort. The most popular serverless platform is AWS Lambda, but other major cloud providers like Azure Functions and Google Cloud Functions also offer similar services. In a serverless model, your code doesn't sit on a running server waiting for requests. Instead, your function, often referred to as Lambda function in AWS, is only triggered when an event occurs. This event could be an HTTP request or a file upload. Once the event occurs, your function is executed and you are only charged for the time your code is running, down to the millisecond. When it's done, the cloud provider scales your function back, down to zero. Imagine an image resizing service as an example. Instead of having a server constantly waiting for uploads, serverless allows you to handle these events automatically when an image is uploaded. The function gets triggered, resizes the image, and shuts down when done, resulting in cost savings and reduced management overhead. To fully understand how serverless works, let's first understand the core components of the serverless architecture. Serverless functions are triggered by events. These events could come from various sources like API calls, file uploads, database changes, or even specific time schedules. Function is the place where your code lives. When an event occurs, your function is invoked, runs the necessary logic, and returns a result. The cloud provider manages the execution environment. This includes spinning up a container to run your function, allocating resources, and even managing memory and CPU. Perhaps the most important feature of serverless is its ability to scale automatically. Whether you are handling 1 request per minute or 10,000 requests per second, serverless scales up and down instantly based on demand. For example, in our image resizing system, the event source would be the image upload to S3, which triggers our Lambda function. The execution environment managed by AWS handles all the underlying infrastructure, allowing the function to resize the image. Lastly, autoscaling ensures that no matter how many images are uploaded, the Lambda function will automatically scale to handle the load. With serverless, you no longer need to worry about provisioning or maintaining servers. The cloud provider handles all the heavy lifting from security patches to updates. Traditional scaling can be complex and costly, and serverless removes this complexity. Your application automatically scales based on the number of incoming requests, ensuring that your app is always available and responsive. In a traditional environment, you pay for running servers, whether they are being used or not. With serverless, you pay only when your code runs. For example, AWS Lambda charges you only for the exact time your function is executing. If there are no events, you pay nothing. And lastly, serverless frees up developers from worrying about the infrastructure, allowing them to focus entirely on coding. This results in faster development cycles and quicker deployments. Now that we have explored the benefits, let's take a look at how it works in practice with real-world examples. We'll build a simple image processing system using AWS Lambda, S3, and API. The first component of our system is AWS S3, where users will upload their images. AWS S3 or Simple Storage Service is a scalable cloud storage service used to store any kind of data. It's perfect for storing things like files, images, and backups. Files in S3 are organized in buckets, which are like directories or folders that help organize and manage your data. You can store, retrieve, and manage any amount of data at any time using S3 buckets. We'll create two S3 buckets, one for storing the original images, and another for storing the resized images after processing. AWS S3 is perfect for this use case because it scales effortlessly and can handle large volumes of image uploads without any manual intervention. API Gateway is another AWS service which will be the entry point where user uploads images. API Gateway sends the image to the original bucket, triggering the resizing process. So we can create a post endpoint such as upload image that accepts image uploads. The API Gateway will send the uploaded image to the original S3 bucket. Once the image is uploaded, the S3 bucket will trigger the Lambda function to start the resizing process. And finally, the star of the show, AWS Lambda. The serverless compute service will handle the actual image processing. It's triggered by S3 and automatically resizes the image, saving the result in resized bucket. We'll write a Lambda function that triggered whenever a new image is uploaded to the original S3 bucket. This function will resize the image and saves the resized version to the second bucket. And here is an example of how you'd write the Lambda function in Python using a pillow library to handle the image resizing. We first begin by importing the necessary libraries. Boto 3 is the AWS SDK for Python, which allows us to interact with S3. And Pillow is a popular image processing library that we'll use to resize the images. And this line here initializes the S3 client, which we'll use to download the image from S3 and upload the resized version back to S3. The Lambda handler function is triggered whenever an image is uploaded to our S3 bucket. The event object contains the information about the uploaded file. We extract the bucket name and the file key, which is essentially the file name in S3 from this event. Here, we use the S3 client to download the image from the S3 bucket. The getObject method retrieves the image data, which we'll use for resizing. Next, we open the image using the Pillow library, and we resize it to 200 by 200 pixels. You can change the dimension to whatever size you need. And once the image is resized, we save it to an in-memory buffer. And then we upload the resized image back to a different S3 bucket, in this case, the resized images bucket. We use the putObject method to store the image in S3 with a new file name prefixed by resized hyphen to differentiate it from the original. And finally, we generate a URL for the resized image stored in S3 and return it in the response. This URL can be shared with the user to download or view the processed image. Now, to connect everything, we'll configure an S3 trigger on the original image bucket, so that every time an image is uploaded, the Lambda function is automatically invoked. And the process flows look like this. So first, the user uploads an image through the API, in our case via API Gateway. Then the image is saved into the original S3 bucket. And so AWS S3 triggers the Lambda function. The Lambda function resizes the image and saves the processed version to the resized S3 bucket. The API then returns the URL of the resized image back to the user. This image processing system demonstrates the power and simplicity of serverless architecture. By leveraging AWS Lambda and S3, we created a scalable, cost-efficient solution that automatically handles image uploads, processes them in real time, and scales effortlessly as demand grows. Best of all, you are only charged for the time the Lambda function is running, making it incredibly cost-efficient. Serverless is perfect for event-driven applications, such as processing uploaded files, handling API requests, or responding to messages from queues. For instance, imagine a photo sharing app where users upload images. Every time an image is uploaded to Amazon S3, it can trigger an AWS Lambda function to automatically generate thumbnails. Serverless is great for real-time data processing. Services like AWS Lambda can listen to data streams from Kinesis or DynamoDB, processing each piece of data as it arrives. And this makes it ideal for IoT applications, sensor data, or even processing financial transactions. Serverless computing fits naturally within microservices because each microservice can be implemented as a small independent Lambda function, making it easy to scale specific service without affecting the entire system. Now, while serverless brings a lot of benefits, it's not without its challenges. A cold start happens when your function hasn't been invoked for a while. For example, if your Lambda function hasn't been triggered for a while and suddenly receives a request, it may take a few extra seconds to respond due to the time needed to initialize a fresh environment. This is what we call a cold start. For latency-sensitive applications, this can be a big issue. AWS Lambda has a maximum execution time of 15 minutes. So if your function runs longer than that, it will be automatically terminated. Long-running tasks might need a different solutions like container-based orchestration. Also, once you build your application with a specific serverless provider, migrating to another provider might require significant re-engineering. Each cloud platform offers slightly different implementation of serverless, making it tricky to move between them. And since the infrastructure is managed by the provider, you have limited control over the underlying environment. This means you might not be able to fine-tune the runtime, network settings, or other configurations as easily as with a traditional server setup. Serverless is starting to make waves in the machine learning space. Cloud providers are now offering serverless machine learning services that allow you to train and deploy models without managing infrastructure. Hybrid architectures are becoming increasingly common, where businesses use serverless to handle spikes in traffic while still relying on traditional infrastructure for long-running processes. This allows for an optimal cost management and scaling strategy. We are also seeing the rise of serverless databases like Amazon Aurora Serverless and Google Firebase, where databases can automatically scale up and down based on demand without any manual intervention. One of the key strengths of serverless computing is its seamless integration with event-driven architectures. This means serverless functions can be automatically triggered by a variety of events, such as database updates, file uploads, or message arriving in queues. If you are interested in learning more, I have done an in-depth exploration of event-driven architectures and how they are leveraged by systems like Netflix and Uber to handle billions of events daily. Be sure to check out that video for a closer look. Whether you are building a small-scale project or a globally scalable application, serverless computing offers an efficient, cost-effective way to focus on what really matters, your code.